so question 31. It's sort of a continuation of question 30. And I've made some updates from the printed slide here. That the block is held against but it's not attached to the spring on an inclined slope at T1. The block's released from rest. T2, the block reaches the equilibrium position in the spring, so I've changed that to say that the T2 that the spring reaches its equilibrium length. T3 passes the rough patch, T4 crosses the rough patch, comes to rest. From T1 to T4 is the magnitude of the change in spring potential energy, greater than or equal to the change in gravity potential energy of the block or its system. So for this question, I will consider the system. In this case, I'll consider the system of the block, ramp, spring, earth system, so everything together in some sense. So because from T4 we have to include this rough patch, so it's more appropriate to consider the ramp and the thermal energy of the ramp plus the block. So there's one external force in this system, which is the force by this wall, but again it doesn't do any work. So the change in energy of this entire system is 0. So the change in energy of this system, though there are some changes, it's a delta U of the spring, delta U grav, delta K of the block, plus delta E thermal. So there's 4 different forms of energy in this system, and we can highlight them here. So the spring potential energy, we can highlight the sort of changes as negative. So the spring goes from having potential energy to having none. It goes from compressed to not compressed, so the spring will, again the block's not attached to, that's important to note, the block's not attached to, and it just gets to, when it reaches the equilibrium position, it stays there. Then we have a plus, we have a positive change in the gravitational potential energy, since the block is raised to a higher point in Earth's gravitational field. The delta K of the block is 0, so the block starts from rest, ends at rest. So it starts at T1 at rest and ends at rest at T4, so this is 0. Plus the delta E thermal, so the block will cross the rough patch, increasing the thermal energy of the rough patch plus the thermal energy of the block. So there will be there is some F delta X in this particular case, and there is an increase in the thermal energy of the block ramp system. So this is also positive. So here from this example you can see that the initial energy stored at T1 in the spring then goes into increasing the gravitational potential energy and also increasing the thermal energy of the block and the ramp. So we can definitely state here that the delta US is larger in magnitude or absolute value than the delta UG with this positive number. So we can sort of think in absolute values that the delta U spring absolute value is equal to delta UG plus the absolute value of delta U thermal. So I can state that delta U spring is definitely larger in absolute value than delta UG. So greater than is the correct answer.